Hello, everybody. Thank you for coming to my talk for Project Panama for Newbies. This is a brief introduction to foreign function and memory APIs. So, a little bit about myself. I'm a developer advocate for Azul Systems, where we build high-performance Java runtimes to help companies reduce infrastructure costs. I've been developing software for over 20 years, and I used to write tech books or tech review books and author some Java books and Java FX books. And you can reach me at Twitter, Carl D, and LinkedIn, and you can always see me at fujay.io, where I blog a lot. And through this talk, if you want to see all the details, go over to github.com/carld/Panama for Newbies, where I go into more detail. In this slide, it's just a brief intro. So as a Java developer, did you ever have a need to talk to OpenGL libraries like native code or even an RFID? Well, if the answer is yes, then it's probably you've heard of JNI, which is Java Native Interface. And if you've not, you know that it's quite painful. So I'd like to tell you a story that, I used to work back in the day where I was on a project, and one of my teammates actually asked me, hey, we need to talk to a native library because it was a server, it was a Java-based app, and it needed to talk to Outlook, and it needed to schedule tasks and schedule events and such. So we came across this library called Jacob, which is a COM bridge or a COM or ActiveX in the Microsoft world. Look at the copyright date. So you know how old JNI actually is, from Dan Adler. He still supports it, by the way. So just an understanding of what the architecture looks like when you use JNI, just showing you the pain points of how it looks. When you write your application, and then it talks to a library from Jacob, which in turn talks to this JNI wrapper code, where it has to talk to the native operating system. But wouldn't it be great if you could just directly talk to the operating system library versus, talking to all these layers of indirection? So the future is now, and Project Panama does that for you. So this is a picture of what Panama would look like, where if you have a Java application, it could talk to the native layer, and of course, it's in the Java runtime. And in the blue, you would see the C application also sharing that library. So typically, in the Windows world, they're called DLLs. I'm sure folks know. It's called dynamic link libraries, and in the Linux world, in Microsoft, or Mac OS, it's called shared libraries. So what is Panama? It's actually comprised of all these APIs and JEPs that exist from left to right. You see the vector API, the foreign linker API, and the foundational ones are the foreign memory access APIs. And then, last but not least, is the ones on the upper right where you see foreign function and memory access APIs. They're a culmination of all the ones beneath it. So this talk is not talking about vector API. So the idea is that this is an umbrella project. So it comprises of all these native access abilities. And this talk is, the code that I'm going to show you is based off of JEP 419, which is the second incubator. So here's a timeline since 2018, starting with the Vector API. And in its inception, this goes even farther back before 2018. So you see on the far right is the foreign function and memory API that we're going to talk about. And this year, 2 months ago, I believe, is JEP 424. And 424 is the same as 419. However, the package name spacing would then go into preview release, which is Java proper. Instead of jdk.incubator.foreign, it'll be java.lang.foreign. So why Project Panama? It's actually a Panama alternative to JNI. I talked to the architects, and they kind of said, well, in the documentation it says it's to replace JNI. They don't really like that phraseology because they want incremental updates where if you have a lot of JNI code, you can do it by piecemeal and actually work on, you could play with Panama and keep some of the old code. If it's so complex, you might not even want to rewrite it. So they don't want to have another, like a module system problem where you either go to modules or not. So this is the Newbies benefits. There's more benefits, but I just want to show the things that you would see right away. So the idea is performance. It's according to the documentation, it's comparable to or better than performance. Because some cases it's about the same or faster because of not introducing those other layers and going directly to the native code. And ease of use, and which we'll find out later, because there is low-level code that you'll see, and then there's a new tool that they created that alleviates a lot of that work. So how does OpenJDK actually talk to these native libraries? They use what is called the CABI, which is the Application Binary Interface. It's a well-known convention and standard in the C days. It's so well-known, if you notice, TensorFlow, right? A lot of folks think that TensorFlow is written in Python. It is not. Underneath the covers, it's actually written in C. And so commanding and controlling like models and machine learning, and you're playing with TensorFlow, it's using Python to talk to the CABI, actually. And of course, if you can actually, with other languages, since they understand the CABI, you can actually create callbacks within Java and pass them into the language, and the language can actually invoke them. So I want to show you some demos. Let's see. Okay, so this example, there's a well-known gaming platform. It's called Steam. Yeah, in the Steam API, there's 3 predominant languages. There's C and C++, C#, and Java. And all the Java games are written using JNI. But wouldn't it be nice if you could just use Panama in those situations? And a well-known framework is SDL library, or SDL2. And SDL contains modules like OpenGL. And so I want to show you what. Okay, I'm sorry. So this is SDL. So it's pretty interesting. It's very performant. It's very fast. I don't know what's going on. So my mouse. Okay. So so what's happening is this window is created by the STL library, and it's leveraging the OpenGL. And the Java is written in Java, and it's passing it into it natively through the OpenGL library and STL. So you can actually play with sound, play with input, joysticks, play music, and render this application window. And I'll have another example later. We'll use an actual Java window or Java FX window instead of the STL window, because this is typically how you write games. So you're actually offloading the rendering off on the GPU. Let's see, what's the other? Oops. I'm sorry. Okay. So my next example is in the library, or I'm sorry, the language Apple's Swift. There's a way to expose things through this using the C ABI. So this function, say something, actually is exposed, and it thinks it's a C program or a C function. And within Java, you can actually call it or invoke it. And so in this example,
hello, Devnexus 2022.
You can't hear that, can you? I'm sorry. Hold on a second. Oh, no.
Hello, Devnexus 2022.
There we go. So I can actually put it in the command prompt. So you can put whatever text you want. So that's kind of interesting. I have articles on that too. If you go to fuji.io, I have a whole, I'm starting a series. The first one is about C++, and you can expose a function as a C API or C function, and then Java can actually invoke that C function. It thinks it's a C function, not a C++ function. And then the second article is on, I believe, Swift, and the next one will be on Python. Okay. So yeah, back in the day, I used to work with satellite data, and we had to map a few things. And so, I don't know if you guys can see this. My mouse is not working. Okay. So good. Okay, here we go. Guys, can you see that? It says Millennium Falcon. So here I have a Leap Motion device, and the Leap Motion device has, the library is actually written in C++. And so the library, I had to, again, expose it so that it thinks it's a C function, and Java can actually interact with it. And it's actually a callback. So in the Leap Motion API, it allows you to know your hand's angle and the yaw and the roll and the tilt or the pitch. Exactly. Thank you. My brain. Okay. I wanted to do something cool, but I didn't have a chance. I didn't have time. But if you go a little bit further into you can see the Star Trek Enterprise right there for the Star Trek fans. So let's see, what's my last demo? Okay, so my last demo here. Whoops. Can you guys see that? So here's a demo of the library called ffmpeg. Has anybody heard of that? Yeah, it's a really cool streaming library. So for use cases like security cameras and such, you could actually have multiple windows and you could stream live feeds or video or MP3s. This one right here is a Java FX application. So this is pure Java, and you're talking to the library, taking the streams. And so I created a glass pane, it's canvas, and I made a little library that it does call outs. So you can see it highlights a thing of interest. And like I made one here for the app. So it's really like I'm just wherever I'm clicking, it overlays this call out. So I thought it was kind of cool. So there we go. For the demos, I'm going to get back to the slides. Hope I'm not running out of time. So let's get back. So where do we get Panama? You can get the latest builds or the EA builds at jdk.java.net/Panama. So JEP 419, there are archive releases that you can get if you'll see it on the page. But probably during this talk or maybe sometime this month or later, the preview release will happen. So maybe the APIs might change, but not much. So just keep that in mind. So if you want to be part of the community, help contribute, tests, demos, talk to the architects, the feedback is at the email you see, panama/dev@openjdk.java.net. So let's get started with assuming you've downloaded everything. Most folks know about setting up their Java home and Java path. You unzip it and you have your path ready. So some self-checks. When you run java-version, it'll give you, it'll say Panama within it. And of course, when you get the production or GA release, it probably won't have that. It'll already be incorporated. So I just want to go through some low-level details, which just going from bottom up instead of top down, just right into method handles. Since method handles has been around for a long time. It's been since JDK 7. So these ideas and talking in native code has always been thought of. So this is my definition of what a method handle is, the method handle API. You could think of it as a Java object that just references a native C function or a C variable in memory. And then you can invoke it however you wish. And of course, just like JNI, you have to set up the property within Java, the java.library.path, so that it can see that library. And usually they're co-located, when you download a jar file, the DLL or the SO or the dyn lib is sitting right there. Or it's installed in in Linux, it's /user local bin, or I'm sorry, /user local. I think if you use brew, it's like seller. You guys get the idea. So here's the long-winded one from, according to the Java doc, since JDK 7. It's kind of very difficult to read and understand. It says, a method handle is a typed, directly executable reference to an underlying method, constructor, field, or similar low-level operation with operational transforms of arguments, or you get the idea. So let's start off with method handles. What you want to do. The newbie term is it's just a Java object with reference to this thing called a C function. So in C, they have these includes. It's very similar to imports, where they also have, it's like interfaces. However, you can pull these additional libraries that you can have access to. And of course, these are system libraries. So when you include them, the function is called getPid. It's very similar to Java. If you don't know C, sometimes you specify a void. It means empty parameters, like you're not going to pass anything in. And the return type is this thing called PID_D. And it's actually, in C language, there's something called a type def. In a type def, you can actually rename a data type. So for instance, if you have an int or a byte or an unsigned integer or something, you can call it whatever you want. You can call it, in this case, PID_t. So with a method handle, this is how Panama typically does things. You create a segment allocator, which new in JDK 18 and above, they have this thing called an implicit allocator, which actually you can create memory off heap. So it's not on the Java heap. So once you get the allocator, you get a C linker, and on the C linker, it's kind of a type of factory function, and this factory function allows you to, when you call the down call, you have to describe the thing that you're looking for. And the thing that you're looking for is a C symbol. And we know in Java, it's a Java symbol, but in the class path or in the library, java.library path that I said earlier, which is the native libraries path where it exists. So it's got to be co-located with it so you can actually find it, the lookup method. Whoops, sorry. So there's a get method on that lookup after the lookup, and it's an actual native symbol class or an instance of it. They're going to probably change that. They don't like the naming of it. So when it goes in the preview release, it may not be called native symbol anymore. But here's the idea of how things are done currently with the API. Here, you describe that's actually a typo, but it's okay. You'll see why. So there's a thing called a function descriptor, where you're describing the interaction between C function and Java function. So because in some architectures, it could be 32-bit architecture versus a 64-bit architecture. So the bit width may be different depending on the architecture. So in some cases, an int may not be 32 bits. So is there a better way? Like here I have an example of a typical C function to open a file. Wow, that's a lot, right? You see a character pointer in C, which is an array of characters. It's, if you remember in college or if you've ever seen C code, that's a mess, right? So doing the low-level method handle way is pretty painful. So is there a better way? Yes, they come out. The team has come out with a new tool called jextract. My wife calls it jextract. So here, if you notice, it's like one line of code. You just call, when it generates this code, you just call the get PID and it returns it as a Java int. How convenient. You don't have to describe it and such. So that low-level code that we saw originally, the generator code will generate all that low-level details, and we'll see that in the next slides. So to be simple, we're going to create a Hello World application, but we're going to look at the anatomy of a C function. If folks aren't familiar with C, this will be a refresher. So here you see the standard input-output.h. It's a header. That H means header. And this is a standard Linux C or standard C way to do console outs and console in. And so here's a typical function like we have in Java, system.out.println or printf. We also have one. And C world, it's always been that way. And depending on how C strings are, sometimes you have to do a flush because of the end of line. It's really a null terminated string. It's not like a Java object. So it's very different in that a string is actually a character array, and everything is a pointer. So the first element is a pointer to that array. And in a main is typically you return a 0, which means that everything's cool. And if you return anything else, it's either an error or status code. So we're going to mimic this in Hello Java Panama using jextract. So I'm just going to go over just some of the really simple options within jextract. So if you set up your Java home, like we said before, it should be available in the bin directory within Java, wherever it was uncompressed. So I'm just going to go through the typical ones. I'm not going to go through all of these. So when you write C programs, you typically compile using this -i. So they're going to kind of transfer the same kind of idea. Just remember it's capital I because, on the keyboard, sometimes when you see it visually, you think it's a letter L. But it's a capital. So, and the capital I includes the header files that you saw at the top of the main function. And so here, -d is simply the same as like when you Java compile something. Java C, you can denote the destination of where the compiled generated files will be, and also the source generated files when you specify it, which I'll show you. -L is simply very similar to GCC and other C compilers. They have this same -l option. It specifies the native library that you want to include or talk to. Like say TensorFlow. In the Linux platform, it's tensorflow.so, and in Windows, it's lib tensorflow.dylib. So you notice the file name is different, and on Windows, it's tensorflow.dll. So in a portable way, just like in JNI, it's very similar in Panama when they do a system.load library. You just specify the name TensorFlow, and that's what gives it the portability within the different operating systems. You just specify TensorFlow, and it knows that if it's on a Windows, it'll take the one with tensorflow.dll, and use that. And so here's the -- source, which generates the source code. If you remember, I said -d to where it goes into the destination. It'll generate those source files and put it in a generated, or wherever you want it, put it when you specify the path. -t is when you target a header file, as I'll show you in a minute, you'll want to have it in a different namespace. Sometimes how it's organized within the generated source. When the generated source gets generated, you don't want it like at the top level. You want it like org.unix or something relative to the library. Like if it's TensorFlow, you might want to say org.tensorflow, and then so all the generated stuff would go under that package name. So let's target standard.io.h. I know it's built into Panama and jextract, but you could still target it to play around with like printf. So the idea here, the objective is to mimic the main C program in Panama. So here I created some environment variables just to eliminate some of this, long path typing for you in the next slide. So here's a Linux version, user local include, depending on the Linux operating system. Sometimes CentOS might put it somewhere else. And there's some notes for Windows if you have Visual source code or Visual Studio Code. Okay, so how do you run jextract? Jextract, like we said before, -d says, hey, I'm going to create a bunch of compiled class files. I want to put them in this directory called classes. Next, I want the standard io.h put in a package namespace of org.unix. And then that long path where they actually are located on a Mac, I put it there. So -h or -I and that directory. And of course, you're targeting this particular header file that you want generated Panama code, that low-level code that you want to just call conveniently. So just a picture of the directory structure here is where the compiled Panama code goes because you specified it in the -d. It goes in the classes and it follows the namespacing and everything goes under there. So the -- source is where you generate the source code. It's not compiled. And -d again, I put it in the convenient place here, generated /source, so that like IntelliJ actually detects that, or most, I think in NetBeans might also. And so it's very convenient. It sets it up, and of course, your IDE will automatically compile and it's available. So when you do code completion, you can actually see all these really cool like libraries that are named similar to the native library if you want to get PID. And it puts it there. So typically, once you have the generated source code, you can set up your IDE. Here is an example of IntelliJ. In the compile properties, they have it in NetBeans and Eclipse. You want to specify the --add modules, jdk.incubator.foreign. You may not have to do that when it goes into GA, which may be 21. That's my prediction. Java 21. It's a long time. So okay, let's create a Hello World program. So here are some imports. I usually like the static imports because that gives you an ability to cut down on typing. So you can notice some of these functions look like the native functions. So it's easy to type. I don't have to say org.unix.standard.io_h. All I have to do is say fflush or printf. So when you start off a program, you always create a scope. And this is the try resources block. And within Panama, you have to create these various scopes. There's different types of scopes, but these are the typical ones I use, which is nice because these try resource, they implement closable. So when you get out of the scope, it cleans up the memory, which is off heap, which is pretty impressive because a lot of the cleanup in C, that's why we use Java, right? We don't care about Java garbage collection. We should, but in C, they typically, you have malloc and deallocate, and it's a pain in the butt. And it's nice because we're kind of doing a lot of work that C, all this is under the covers. So once you get out of here, it closes and it's really nice. So inside that do cool stuff, what you can do is say you want to create a string. Of course, that string is, you're creating a C string, not a Java string. So the idea is that there's this class called a memory segment. Keep that in mind because that's the most important class as far as the memory access API goes, because that contains a reference or a pointer to the thing in memory that's referenced within memory out of the heap. So there's this C array in memory with a null terminated string that's referenced in this this instance called memory segment. So here, afterwards, you just invoke the printf like you do in C. So if you ever go to Stack Overflow and you copy and paste C code and you want to put it in Java, you can actually do that. So here, you have to do flush because in cases where you're playing, if you're in the Java world or you're in the C world, because here, in this case, you're in the C world, right? So if I say I don't do the flush, right, and I do the printf, I'm printing a C string out in their standard output on their console. So there's a reference to that pipe. Now, if I do a system, I'm in the Java world because I'm typing here, and I type system.out.printf or print line, and that's a Java console out. So that will come out first before the C one. So the ordering, you'll notice an ordering problem. But so if you flush it here, and then you do the Java system out, it'll come out in the right order. So how do you create a C memory segment instance, which is a C array of characters, into a Java object? So they have a simple method off of the memory segment instance, that object that I described. It's called getUTF-8 string. And you have to put an offset because they made it so that it can be used for other memory or value layouts, which I'll talk about later. It's the idea of, in C, they have these things in memory, in a memory address. So they have they don't know how to stop. So like you have a character array, it's like, how do I stop? But because you're saying this get UTF-8 string, it kind of knows where to stop, but you just put 0 because later you can grab like an int, it's 32 bits. And if you're in a different operating system, jextract will create these other data types for you that map to the actual native operating system's architecture. Because if you're on like Raspberry Pi or a 32-bit operating system versus a 64-bit operating system. So here it's just a regular string used like in Java. So maybe some C function is returning some status and it's in a C string and you need it, but your application needs it as a Java string. So how do you run it? you saw the main, you saw the scope, and now you have the allocator, and you've just built your printf. Now you just want to run it, and here you have to enable this. It's called enable native access, all unnamed. It's probably the unnamed modules. And then you have to add the module jdk.incubator.foreign, and then the application. You could actually, if it's one file, the new Java, I think it was Java 11, that supports, you can run a single file without having to compile it. So that's kind of nice. It's almost like a script file. So that's the output. So we're going to go into just simple memory allocation. So like I said before, jextract does a lot of really interesting things. It does all the low-level code for you. So in my IDE, it kind of describes the data type of the var, because var cuts on typing. So the implicit allocator will allocate something off heap. What I'm trying to do is creating a C double, and you can create all these other types like a C int, the C double, or a C pointer. So here I'm just simply I want to allocate a C double, and there's another overloaded method that allows you to just set it. So I'm putting math.py into it. So I just wanted to show this in the Java doc. It just shows that it's a native allocator and that it's literally off heap. Okay, so here are some of the ugly details of what jextract actually generates. There's a new inner static class called off something, like off byte, off short, off int. That is part of Panama and the value layout class. So if you ever look at that, it's interesting to look at. But what jextract actually does is dynamically generate things that map to what makes sense to you as a Java developer, and seeing things as C, you're just accessing a C library. So you just think of it as a C underscore char or a short. You're just using these. It's just a mapping to the data type of what you're trying to target. If you want to create a short or an int or a long, it maps directly to the C equivalent. So here's a simple example. It's almost like a bean class where you have getters and setters. However, you have an extra parameter that provides the offset. So again, very important. The instance or the class name memory segment is very important. It's not going to change. That's going to be that name, but that is a object reference to the thing in memory for the memory access API. So C double, you want to get that value out of there. It's going to be C double. They may change that API because you know the type. It says C double. I know from the mapping it's 64 bits. It's 8 bytes. Why do I need an offset? So maybe they can cut down on. They might change that. And of course, you want to set the value. I think I said it the other way around. But setting the value, again, you have to type in the offset, and the value you want to set it to. Okay, so this is the next thing is creating an array of those memory segments. It's still a memory segment, but invoking the allocate array of the type you want and just specifying the array will actually create these values. So you can, it's almost like you're coding in Java, but you're really putting this stuff in memory. So there's an array of doubles in memory off of the Java's memory heap on the C world. It's kind of nice because if you're using some GPUs, you're doing high performance or some like matrix math or something, you want this library to do all this work off of the CPU. So some of this, all the copying is really expensive, but if you can operate within the memory bounds within the C world, it's just so much faster, right? You get the results, you just copy the results, or you can keep it in the memory segment object and operate off of the memory segment object. It depends on, context switching, how much you want to put it in the C world, how much you want to put it in the Java world. So simply a double is 8 bytes, and it's consecutive in the first row. It's 0 relative. So they have a convenience method. It's called get@index. So you can actually treat it instead of the old way, in the older API, it was very difficult. You had to know the size of the double. So you have to specify how big you want it to increment in memory. So you have to know how to get the value layout within the array. But now you just specify the index. And so number 2 is the 0 relative. So index 1 is the next row of numbers. So here I just output what was inside the array. So here's the output. So we're coming to a close, and here's the summary of what we've learned today. So, the what, where's, and how, and the low-level method handle class, and jextract to simplify a lot of things, and the memory segment, as we described earlier, and value layouts. I have other slides that we can take offline, but there's other ways to create things in memory. There's another class called the memory layout class, which allows you to create structs. So you're mapping things that are in the C world that you could actually build. So mimicking and understanding what you can do in the C world it's really powerful. For instance, if you can, map structs or map even pointers, just doing what pointers do, you can actually save space, because when you call a Java function or a Java method, it's actually calling by value. So when you pass in a value like an int, right, it's actually copying that value and it's creating another local one within that method. So then it calls another int function and it copies another one. But if you had a reference to that variable, it can actually change that variable. So there's no copying going around. So it's really passed by reference. But if you can mimic that in the C world using Java, using Panama, it's incredible. So you can optimize however you want or mimic whatever the library needs, because my blogs actually go into more detail on like how to create a pointer and such. So see, there's a lot of pointers. So yeah, there's C pointers, there's C structs, there's callbacks. We don't have time to go through, and some of the demos that I showed you about Polyglot. So if you want to get into more details, just head over to my github.com/carld/Panama for newbies, and it'll go actually to fuj.io and show all the other the advanced topics. So, any questions? I'm sorry? Yes. Oh, no, you can't. So a lot of, so C++ also has a C++ ABI, and it's very complex and very messy. There's so many, it's not really standardized, and a lot of, like TensorFlow didn't choose it. So trying to mimic it is very difficult, but they do have that facility to expose functions, like I showed you about C++. But what you would have to do is mimic that class, create a struct that mirrors that class. So if you have data members, private, public, you're basically creating a struct equivalent to it. And then that can be used because that's C ABI. And Panama, Python C can talk to that struct. So that's. Yes. Well, so the sentiment is it used to be thought of to replace, but the idea is it's an alternative. So you can take your time, or if old code still remains and it's very complex as J&I, you may want to leave it alone. So, but you can incrementally move. But if it's newer project, it's awesome. I mean, there's a lot of great possibilities. There's a lot of threading problems that you would encounter in J&I, and it's a lot to manage over time. So.
Maybe it's nice because a lot of the new things, for example, machine learning and everything is in Python, and if we can do this interface with like Python libraries to Java, then that can definitely work for people who already know Java and do all these, like for example, if I would like CUDA libraries, there's JCUDA, but if I can do this interfacing to CUDA libraries to Java using this, then I can see.
Absolutely. Yeah, I do have an example. I don't know if I could show you, but I have a TensorFlow model that's loaded and run. But I mean, it's supposed to do character recognition. But yeah, it's pretty easy to do. It's very promising. Any questions? Any more questions? Thank you. Have a great conference.
Give me some ideas for my TurboVision.
Oh yeah. Did I send you?
You did, yeah.
Okay. Yeah. If there's any help, yeah. The struct guy. That was a good question because I actually did that the other day. I had to mimic a class. Thanks, brother. How do you do? Awesome. Thank you. I feel better.
Yeah.
So yeah.
It'll completely change how I approach that.
Okay. Okay. Oh, that's what I didn't say in the video, but when I was telling. Oh. Oops. Yes. But like optimizing method handles